Thank you for the reminder, always. Okay, I was just give everybody a moment to arrive. I'm just kind of cleaning up my desktop environment a little bit. So it's not so, when I go to switch screens, I don't have 20 screens. All right. Small group today. Still maybe a lot of people sick. How many people went to Goa?
I think around 40, 35 or 40.
Wow. Okay. And that's totally on the other side of the country, right?
Yeah, for us, I think yes.
How long of a flight?
Direct flight from Bhubaneswar is like 2.5 hours.
Okay. Wow. Okay. Exciting. Oh, looks like we have a very small crew here. I'll give everybody one more minute. I think everybody's pretending that they're gonna watch the video. Well, today's I would say a bit of a technical presentation, so it probably, uh, uh, I don't know. I mean, the really big technical guys like Rakesh and Evan, they're going to dig this, and Suvam, of course. So we'll see. But what we're going to talk about is, the last couple times we've talked about MCP agents, and we've focused mostly on the server side. And the reason for that is the client is kind of embedded in the host. So if you use LM Studio, or if you use Claude, desktop, like I've demonstrated both of those, showing the server running in both of those. If you use those, the client is inside of those. So, you don't really see the client side working. So why are we going to talk about it? Well, it's architecturally important. And one of the reasons is there are the way that Claude Desktop and LM Studio implement the client give you some limitations. So we talked in brief about a bunch of different things that can be done on the server. And I'm going to go through those again today because I want to highlight to you that very few of them are actually implemented in most of the models and most of the apps that are out there right now. But there's some really cool stuff that you should be aware of. And if you're this class is all about writing our own apps, right? It's not about just using a chatbot. So if we want to write an agent and we want to use that for our own app, we want to understand what's available on the client side. And maybe we want to write our own client. And that's kind of what we're going to do today. I'm going to gloss over some of the code because it's a little bit complicated, but you'll have access to it and you can go in and use it as an example and modify it. So let's get rolling. So we're going to talk about the client side today of the client server interaction and kind of all the things that does. So last time we built an MCP server. Hopefully your trips didn't completely wipe out your memory. And this week we're going to look at the role of the client and understand the interaction between them. So the other experiment today is I wrote out my outline and I used a service, an AI service to generate the slides. It's my outline, but the slides are kind of made pretty by a thing called beautiful.ai. So this is an experiment too, because I kind of finished this at the beautification at the last minute. So we may find some interesting little things. So basically what we've done, or what I've done, is I created my own command line interface, because if we use, let's say, LM Studio, we're limited to what the guys at LM Studio have implemented on the client side. If we use Claude Desktop, we're limited to what the Claude Desktop people, and generally what they've implemented are tools, and that's about it. Maybe resources and maybe prompts, but barely. And so what we're going to do is we're going to implement those on our client and our command line interface, and show, what the it allows me to show you a little bit more of why those are interesting. And then we're going to go into some even more interesting stuff, roots, especially for security, and sampling, which is kind of a cool concept. I'll wait until I get there to really discuss that. But basically, the clients, everybody's familiar, I suppose, with the concept of a printer driver. Maybe that's old technology, but the idea is that inside of your word processing program, like Microsoft Word doesn't know all the details of every printer in the universe, okay? It just knows that it needs to print something in a particular font. So it and it doesn't know how to eject a page. It just has a command, eject a page. And in between the physical printer and Microsoft Word, there's a printer driver, probably in the operating system, that's managed by Mac OS or Windows. And that printer driver is a bridge between Word, the host application, and the physical hardware of the printer. And so Word just says, eject a page. It sends that to the printer driver. The printer driver translates that to the specific command for that brand of printer, that model of printer, to eject the page, right? The client is a lot like that. It stands in between the host application and the server, and it has a sort of a standardized interface so that every host application can just say, look up a tool, give me a list of tools. The client will communicate with the server to get that list and give it back to the host. Okay? So that's the purpose of the client, is to stand between the host and kind of standardize this interface to the server. The server will have standard thing, just like every printer can eject a page, it can print a character, it can change fonts, it can do all these things, change colors. But they all do it in a little bit of a different way, and Epson does it a little differently from an HP, etc. So we have printer drivers that stand in between. Otherwise, you wouldn't have to install anything when you buy a new printer, right? So inside of the client, then we're going to have some standardized things. And one of those is the MCP Client class, which provides a structured way to connect to the server, to manage sessions, and to implement these standard functions. So the client, the biggest thing it does is it connects to the server using the MCP protocol. It allows the discovery of what the server is capable of. It executes the operations on the server at the command of the host, and it just enables easy communication between things. So it's a nice bridge that standardizes everything. So if you remember, we use the concept of a USB standard. This is kind of the bridge. This is your cable in between the host and the server that standardizes the connection and allows things to happen in a nice way. So again, we've got the client, and the MCP protocol is the messaging standard that it uses to talk to the server. Pretty straightforward. I mean, the MCP protocol is basically just a bunch of JSON standard stuff and a format that allows messages to go back and forth between the client and the server. So some of the client operations that are standardized and allow the host to make use of it. So the host has to kind of know what the possibilities are. So the host can say, if the user types in, give me the weather, the first thing that the host is going to do is it's going to go and call and ask all the MCP servers that's attached to, give me a list of your tools to see if anything is helpful in answering this question from the user. Now, it's probably going to do that once, and it's going to cache those answers because they don't change over time. So for efficiency's sake, it's not going to do a list tools every single time. It'll probably do that when it connects to a new server, and then it'll remember those answers in this session. You start a new session, it'll list the tools again. So then when it has that list of tools, it keeps that in its context. And anytime the user asks a question, it'll refer to that list of tools and the descriptions in there and say, the user said, get the weather in Portland, Oregon. I do have a tool that gets the weather, so I'll use that. And then when it does that, it'll use the call tool function, and in the list of tools, it will have the protocol, the arguments that are needed, and the specific protocol needed to call the get weather tool. So then it will wrap that up in a call tool. That's just a message to the server. The server will get that message. It'll unwrap it and it'll see, I'm supposed to call the get weather function with this argument of Portland. It'll actually execute that. It'll then wrap the answer up in another message and send it back. So these things, all of these things are pretty much two-way functions. They're going to go from the client to the server. The server will create a response and return it. So a couple of the other things we talked about last time on the server side were resources. And a resource is a read-only type of thing. Maybe it's a file that's on the server. Maybe it's a database, but generally it's not a function that's executed. It's data that will be returned. Now, behind the scenes, there may be a function to go get that data, but the way it's not a dynamic thing from the standpoint of the client. It's a read-only data source. Generally, you're getting this stuff in order to fill up your context with information so that the LLM can process it on the host. We have prompts. These are templates that can help the user formulate a finely tuned prompt. We'll do some examples of that. And then routes. So that has to do with what directories and files are available on the client side. So just to emphasize this, because I'll repeat it a couple times because it certainly confused me when I was learning it. Resources are on the server side. They're read-only resources. Think of them as a file or set of files on the server. Routes are directories that the client can pass to the server from the client. So this would allow you to, say, set up a directory on your machine that the host can then use to pass as context and can pass to the server. So it limits what's accessible. So you can't, the idea would be you can't just say, read every file that's on my system and start erasing it. It tries to create a sandbox. It's a way to create a safe, secure sandbox on the server side. So the resources are on the server, roots are on the client. And roots are basically directories that are safe to give information from the client side. So inside of the MCP client class structure, we just have exactly what I was talking about, except a couple of extra things. We have a connect. This is the very first thing that has to happen. We connect to the MCP server, and that establishes a session. So just like a lot of things, just like a lot of client server things that you've dealt with in programming, you're going to set up a session. And the nice thing about it is one of the biggest reasons we do this within a class structure is that when we're done with the client, we close the session and it cleans up for us. It kills a lot of resources that we created, etc. A little technique, and I'm not going to go into this too much, but generally, because this might be in a multi-user, multi-tenant situation, we wrap everything with Python async and awaits, and that allows it to run with multi-users, and it doesn't block things. So it's just a technical detail. If you were going to write this for a single user, I don't think that'd be particularly important, but it just generally allows things to keep flowing no matter how many users are using the server. And then some basics, super basic things: list all the tools, call a tool, list resources, things like that. Those are going to be inside of this class. They're the basic things that every client needs and will be exposed to the host and ultimately to the user in their queries. So again, tools, they're basically the reason for the MCP protocol to begin with. And so in the client, we need a way to discover what tools are on the server. So the client is not going to have a built-in list of tools on the server. The client is generic. The client could potentially call multiple servers. So we need to keep it very generic. And what it has is a list tools, and it will ask the server, hey, what tools do you have? So if you remember in our stupid weather server, we had get weather, and I've added some new tools for this week so we can see a little bit more sophisticated list. And again, the way that the host can do something via the client is through tools. Think of them as remote function calls, I guess. Probably one of the simplest things to do. And that remote function call can do lots of stuff. It can go search the web. It can read data from a database. It can, parse a web page and extract data like our weather server, stuff like that. So tools are extremely variable. Think of tools as making up for things that the LLM isn't very good at. So mathematics, for example, a lot of tools do math because LLMs aren't very good at math. So the list tools operation, clients just use this to go get the list of tools, and it's pretty straightforward. And in fact, usually you can even ask the chatbot, hey, what tools do I have access to? And again, as I said a little bit earlier, once you have a list of tools and the way they are parameterized, you can then execute a tool on the server by using the client's call tool operation. So the host will say, hey, client, use call tool to get the weather. Okay. The big thing is the tool has metadata. Our example from last week, we had get weather and it required a location string. So we have to tell the client that. So when it does a list of tools, it's going to return the name of the tool, a verbal description of the tool, what the input schema looks like, and which includes the parameters, and what the output schema will look like when it comes back. So that way the client knows how to format up the request to the server and make the function call, and then it knows how to process the data coming back. So it'll get a list of here's what you're going to get back, and it'll be just a quick JSON kind of structure. Now resources, we haven't talked about those yet. Again, they're read-only content that's on the server. Examples are like maybe we have an about the server. We might want to be able to look at the config of the server. We might want to be able to look at the status of the server. We might have a README file. We might have 25 documents on the server that we could request that the server provide, and it would come in to our context in the LLM. So they would be, think of them maybe as standardized documents over on the server side that are part of the server's knowledge. With our weather server, we could possibly have a whole document about the weather and what certain things mean. That it could be a very long document potentially. What's a thunderstorm? What is hail? That could be pulled into the LLM as context, and then when we get the actual weather, it could be used to interpret the weather. So I'm going to switch over and just kind of show you this little command line interface that I've built. So I have the stupid weather command line interface, and it starts up the server. It accesses the client, and you can see all I've got is a tiny little prompt here. So I could say just hello. It's just a chat bot at this point. And it knows that it's focused on the weather, but it also has some file reading stuff. So I can say, what is the weather in Rourkela, Odisha today? Oops, I misspelled Rourkela. Hopefully it'll figure it out. So it's using the server to get the weather, and it's using Claude behind the scenes to process the return response. So here's our response. I don't know, Taran, is this accurate?
Yeah,
Does it look,
no,
is that today's
no,
weather in
no, it's
Rourkela?
too cold.
52
It's
degrees
too
in the,
cold
yeah,
here.
yeah, okay. So that's the basics, so that's using the weather tool. But resources, I have implemented a little bit of a different thing. And if we type slash, we get a pop-up, I'm sorry, at, these are our resources that are sitting over on the server. So this at is just a quick key binding. If it sees at, it immediately gives me a list of what are the things over on the server that I can access. So I can say, well, what's the current configuration of the server? And it's just going to read that and return it. It's going to read the refile. So it says, don't have one. So yeah, I think I deleted that. So all right, what else do I have? I have a README file. So I can say summarize at README, and it'll pull the README file in from the server over to the LLM and summarize what's there. So basically, it's okay. So I said summarize README. Here's the response. This file explores building MCP clients. It shows how to quickly set up things and so on. So pretty straightforward. It just read, and over here is the README file. So you can see the README file's pretty big, and we got a short summary of it based on what I just did. So you can combine the reading of a file with the services of the LLM by building this. So again, a lot of the host chatbots and stuff don't really have this built in. And that serves as a little bit of an introduction to the command line interface that I built. So now if you look over here in the code, we've got the server we built last week. We've now got a command line interface, and now we have a client. So the command line interface, in order to do any of this stuff, will call functions in the client. And you'll see right here, we just talked about the class MCP Client. And inside of this class, remember we talked about the connect, session, list tools, call tool. All of this is implemented inside of that class, all of these standard things. Here's our list resources. So when I typed @ we got the list of resources. That's that piece of code being executed. When we actually, said summarize, it used the read resource for the particular resource we asked for. So why would we do such a thing? Well, resources are handy. Again, you could put lots of context documents on the server that are meant to be used with that server tool. So weather explanations, you could say, get me the weather and explain it using @ weather terms, and stuff like that. So lots of good stuff. Maybe that would be a good assignment for you to work on, is to create a good document that could be used with our weather server. So resource operations, just showed you we can list them. That's what happened immediately when I said the @ now, we're not limited to the little @ thing. In fact, if I come back here, I should be able to just say what resources are available on the server. Hope I haven't tried this, so it may or may not work, but it should use the resources. So here, it does list available resources, returns the README documentation, app status, returns the application status as JSON, and the config, which we saw caused an error because I didn't put anything in there. So we could, we can say, show me the app status. And this is just a little fake thing that I did on the server. It returns the server name and version, the uptime, which is fake. So we can say show @ app status. So now it uses the official name, and it will return the JSON. Status is okay. It's been up for 1, 2, 3, 4, 5 seconds, and it's hosted at localhost, which is correct. So the uptime's fake, but the other two items are actually correct. And then the LLM actually processed that and gave us an interpretation of it. So that's an example of resource. So we listed the resources. We did a read resource for both a file and a more dynamic thing like status. Just on the server side, it's going to wrap it in a type, and that will be used by the client side to understand what it's getting. So usually it's the two MIME types are going to be either text or JSON, and that tells us how to process it on the server side. So let's talk about prompts. We did this just briefly last time. These are templates, basically. So you can create a really nice template, and we did one last time, which changed the role of the chatbot to be kind of a crazy hippie weatherman. And we can put variables in there like the location. And so then we wrap the prompt, and essentially it just creates a more sophisticated prompt, which is brought back to the LLM, executed, and sent off to be processed. We can write those prompts ourselves, but let's say we want to give the user a bunch of pre-built prompts that we've spent time as the developers very finely tuning so they give really good results. Like the weather service, we can give it a role of a very sophisticated weather reporter. We could give it an academic voice, go deep into the explanation of the weather for this location. Or we can give it a different voice, like I just want to know what the weather is going to be on Friday. So we can create prompts that change the tone and voice of the responses. We can create context. We could create a server with a bunch of different prompts that just do different things in different ways, and they're much more structured, and we can spend time tuning them and give those to the user as starting points. We can create things that summarize documents or even generate test cases if it's a coding thing. So a lot of agents, I'd say, feels to me like a majority of the agents are focused on coding right now. So a lot of agents specifically have tuned prompts for things like generate test cases and so on. So if I go back over, yeah. So I'll go back over here and show you what I'm talking about in our CLI. So in the prompt category, remember for resources, we typed an @ For our built-in prompts, we have another shortcut, a /. So remember last time we did hip weather. So we just give it a location. Give me the hip weather for Portland, Oregon. And it's basically going to go to the server. It's going to get that prompt. It's going to substitute a variable with Portland, Oregon. It's going to bring that prompt back through the client to the host, all fully built out. And then the host will submit the full prompt. And this is our result. So if we look at, again, look at the code on the server side, we've got our hip weather prompt, which we just saw, and the definition is right here. You are a weather reporter. Give the weather report for location in the style of George Carlin's Hippy Dippy Weatherman from the 1960s. Okay, so that's one prompt. I created another prompt, get the weather with context. So what it does is it includes resource data. So it's going to prompt, it's going to embed data into the prompt from a local resource. So I have kind of a trivial example here. It's going to get the status of the application and put that in the prompt as well. And so here's our prompt. You are providing a weather report with application context. It's going to get the application status. We ran this, and that's going to give us the uptime of the app and so on. It's going to review that application status for the user. If the status is not okay, warn the user about issues. Then it's going to get the weather, and then it's going to provide a comprehensive weather report. So if we go back to our command line interface, we get weather with context. It still needs a location. And it's going to create this fairly large prompt, which will include the status of the application. Okay, so we got to scroll. It's a pretty big prompt. So here's the response. Here's weather report for Minneapolis. It first did an application status check. All systems are operational. So we know that our weather report is viable. Then it gives us the current weather conditions in Minneapolis. Taran, you said it was cold in Rorkala. Well, it's 22 Fahrenheit in Minneapolis. So a little bit colder maybe, with light snow showers and 14
Yeah.
mile an hour winds. It's going to be 11 degrees as a low tonight. So think about that. 11 degrees and snow. And we get an extended outlook. 5 degrees for a low on Saturday. So we can say we'll just give you guys -15. So that's the low tonight in Minneapolis, or low tomorrow. I guess that translates to brutally
It's
cold.
deadly.
No, that's not deadly. That's not even close. It gets a lot colder than that in Minneapolis. So that's kind of getting ready for the winter. That's just an early warning for what's coming. Okay, so that's prompts. And again, the idea is to create a set of really nice pre-built prompts for the user to have access to that are tuned and ready to go. So the next thing we can implement is on the client side is roots. And this allows access to your local file system. So remember, resources are on the server and prompts are on the server. Roots give us the ability to give our local files from our client to the LLM. Okay, so it creates a sandbox. It creates safety. So it's pretty straightforward. You just have to remember that roots are unique in this system. They're on the client side. Why do we want them? Well, they prevent the LLM from just reading anything on our system. So we're only going to provide things from safe directories, let's say. So it keeps us from getting into sensitive areas. We could even implement something that says if it's a .env or if it's a secrets file, even if it's in a directory that we have access to, don't share that, because that means sending secret keys up to the cloud. We don't want to do that. So we could build whatever we want. And basically what we have to do on the client side is we have to build the functions that implement this stuff. They're not built for us. The protocol just says what they're supposed to do. We have to actually implement them. So if we want to implement roots for this safety, we have to build a function called read file safe that validates the paths against the allowed roots. and maybe builds in some extra security. It could even, I mean, we could get really sophisticated. And there's a concept called PII, personally identifying information. So this might be your government ID number, your address, your health information. We could put a scanner in there that scans the data that we're trying to access and say, look, I know that's in your safe area, but it contains personally identifying information, so we're not going to allow you to load this up to the LLM. So we could implement corporate security standards. We could do all kinds of things within this, but it's up to us. The other thing is, remember, so think ahead a little bit. If we're building a real server that's going to be hosted in the cloud, and we're going to all get rich because we're going to make a MCP setup that millions of people will pay for. Well, everybody's going to access this, and they all have different security situations on their own laptops. So each one of them will have to configure their safe directories per their own setup. We don't know what's safe for them. So we have to do things that allow them to mark what's safe and respect that, but it's up to them to do the marking, I guess. So again, just like prompts and just like tools, we have a list roots that will give us a set of safe paths that we're allowed to access. And so we would call this to get our list of available paths that are safe. And then once we have that, we have a read file that allows us to read the file and give that to the LLM. So all of this is really happening on the client. This does not really involve the server at all. This is all on the client side. So us, we have to have all the stuff to evaluate paths. We have to ensure that the resolved paths start with a available allowable root directory. We have to reject attempts to escape the sandbox using symlinks or other techniques, and we have to return errors. So, for example, if they were to call, they say, show me what's in logs system.txt, we would evaluate that by making sure it falls under an available safe directory. So we resolve the path, we check it against the available roots. If it's valid, we give the file contents. If it's invalid, we explain why. So here's we could write an agent that's our weather agent, and somebody says, hey, tell me what's in log system.txt. Well, within the context of a weather agent, that makes no sense. So we probably would reject that because it's not in the safe pathways for a weather server. But what if we built an agent that was a troubleshooter? It's going to need access to system logs. So the user would put this logs directory in the roots, allowed roots configuration, and then we would have access to system text. So you can see it's very context dependent on what it is that we're trying to accomplish, what our agent does, what our server does. We have to be really careful. We have to avoid lots of different security issues. We can't allow too broad, if somebody puts in slash as the root, then we have access to everything. So we may want to put in some things to say, hey, your root definition is too broad, but we also may have to leave this up to the user. What we want to make sure is we don't open up a gateway for attacks. I think that's the critical thing. And then the clients are going to have to trust the root definitions. So let me switch back over. I'll show you kind of what we're talking about in in reality here in a demo situation. So first I'll show you. So here's my config, my secrets. So I've got my Anthropic key, I've got which Claude model I want to use, etc. And then I've got this thing. So I have it allowed, it can access the directory that I'm currently in, you can see. So I gave it access, and we can put commas here and we can give it a whole string of things that we're allowed to access. For right now, we're allowed to access this current directory. So I can say, list the files I have access to. So basically, this is like doing a directory command, right? But it's doing it through the LLM, and here's it gave a nice little status that it said it's working on it. You have access to files in here, and here are the files you have access to. And here are the directories you have access to. And then it interprets this. This is the week 10 project directory this is from the LLM. It kind of interpreted what's going on. So we can now say, summarize briefly the file teaching outline.md. So this is on the client side. And notice it says access granted. So it went through our security thing, and it noted that it does have access to it. And then it reads the file, gives it to the LLM with the instruction to summarize it briefly. And boom, we get, this is a pretty big file. It's my outline for all the slides you're looking at. So it's got a lot of content. So it just kind of broke it down, part 1, part 2, etc. So it provides detailed slide-by-slide content with code examples, diagrams, and teaching information. So this is what Roots does for you. It gives you access to directories. And once you have access to the directories, you can do things like ask what's in them, use the content of the directory as input into the LLM, and so on. So I think this is a really important one. Let's see, I think I've got kind of a little bit of a duplication coming up here, a little bit more. So that's Roots. Going to skip over the next section because I think my slides kind of duplicated themselves. So we've got list prompts, we got get prompt, we already saw that, prompt variables, we did the weather summary prompt. So that's duplication. Okay, last thing before we wrap up for the day is sampling. And I briefly touched on this when we talked about the server last time, but this is a really, really interesting thing. So what if our agent needs access to an LLM? What if our agent wants to do something really sophisticated and it wants to use the services of an LLM? So sampling is the process where an LLM generates text based on a prompt, but it doesn't use its own LLM. Okay? What do I mean by that? The client prepares the message, and then sends it to the server. And the server says, hey, I've got a tool that requires an LLM. And I've built an example of a tool that does a little bit more of weather analysis. It advises you on what to wear. It doesn't just show you the weather, it advises you on what to wear. Well, how does it advise you on what to wear? Well, it needs an LLM to do that. So we have a couple of choices. I'm trying to get to a slide. Yeah. I don't like this. It kind of went off. Okay. All right, forget that. I'll just show you an example and we'll talk it through. My slide creation went a little bit off the rails there. So if I say, what tools do I have? Let me just expand this a little bit so you can see it better. Okay, so I've got get weather. And I've got, if I go, you see read file safe, we just discussed that. List files, got a couple of other things we can talk about. We got get roots, we've shown that. So here's get weather advice. It gets the weather and personal advice for an activity, and it uses AI sampling. So if I say, what advice do you have for what to wear in Minneapolis tomorrow based on the weather? Okay, so I built in some things so you can kind of see what it's doing. So it's starting the weather advice request. It's initializing it. It's validating API credentials. It's fetching the weather from SERP API. That's all standard. It's querying the weather service. It got the weather. The temperature is 23 and light snow. Now, consulting LLM for personalized advice. And just a sec, consulting the LLM via sampling. This is where the magic happens. It's asking the client. So let me break this down a little bit. So the first couple of steps, it's just the normal get weather stuff up through here, right? That's just getting the weather. Same stuff that we've done before. But in step 3, we start going off in a different direction. So it says consulting the LLM. Now notice, here's where the interesting thing is. Consulting the client's LLM via sampling. So this is what sampling is. The client is embedded in a host that has access to an LLM. That's the whole point, right? The server is just a bunch of code. It does not have a connection to an LLM. We could create one, but that's complicated. The client already has one. So what we're going to do is we're going to form up a query and we're going to pass the query back to the client that's already connected to an LLM and say, hey, buddy, run this query for me through your LLM. Then it waits for that response. And here's our, we're in the middle of sampling. It created a sample with a max tokens of 200. It generated the LLM generated a response. It got the response back and it forms that up and sends it back to the client with the weather data that it already had. And all done. Here's your weather advice. What to wear in Minneapolis tomorrow with temperatures you need: a winter coat, a hat, a scarf, insulated gloves, non-slip boots for snow. Wear multiple thin layers. This is classic Minnesota weather. I'm not even sure it's just winter weather. It's kind of weather any time of the year. So why do we do this? A huge reason is if we're going to create our server that 1 million people are going to use, if we connect to an LLM, guess who's paying for that? Us, with our server. And we're locked into a single server. We're going to call Claude Sonnet 4.5, and they're going to charge us millions of dollars a month because our service is so popular. But the client is already connected to an LLM that's the choice of the user. The user is already paying for that connection, or it's a free one. So we're going to sort of be a parasite on their connection. And what we're going to do is formulate a query and just pass it back to the client. The client is going to run it against the user's LLM and send us back the answer. And then the server's just going to combine all that and send it back as the answer. So that's what sampling is. It's sort of being a parasite on the user's LLM connection and using it to do sophisticated AI stuff. Okay? I hope that makes sense. But this is an example of it. And the last topic I wanted to talk about was also the ability to add progress and logging to this. And if you remember when I asked what tools I have, I actually built some tools inside of the server and the CLI that allow us to toggle a debug mode. So you saw, I think we had a debug message in here. I can turn that on and off by just saying, turn off debug mode, and it'll call the debug mode tool and just set a flag in the server that says debug mode is now off and debug mode is now hidden. This is not a debug message. This is an info message. So certain tools provide info messages, which are considered logging. And I don't know, I guess I got off track over here. But anyway, not important. The idea is logging was the last thing I wanted to talk about, which you can log for debugging purposes. And I have this special tool. So I can say, to demonstrate logging a little bit more clearly, I can say, get the current weather in Amsterdam with logging, and it'll give us the progress as it goes. So you can see 33%, 66%, 100% successfully retrieved the weather, and here's the weather. So in your tools, and I could implement a tool that says, always do this for everything, but have the ability to maybe toggle it on and off. So that's kind of what I wanted to talk about today. Just expose you to all this. All of the code is in there. So you can play around with it if you want. You can add new tools to this. You can add new client-side capabilities. You can change the routes, make it work for your system. And as long as you have an API key for Anthropic, which you can, I'm not sure if you can get a free one, but you could rewrite it so it uses Grok and use free Grok. Or one of the other, use Open Router or use LM Studio. You might have to change the code a little bit. So that's what I got for today, guys. Any questions? Thanks for being the troopers that showed up.
Yeah, of course. Thanks again, Tom. Appreciate it.
This was a little bit of an advanced topic. I mean, I'm not sure. I think if I'm in the middle of writing a server agent MCP thing for Viori, so it's kind of hot on my mind, and I'm implementing some of this stuff. So it is, kind of vitally important to me. I guess it's a little bit cutting edge because, as I mentioned, a lot of this stuff is not even implemented in the current chatbots and stuff. So you're getting an advanced look at what's coming. This stuff will happen.
Right. Well, so I guess that's good, even if, it's a little bit, if the coding specific is a little bit over somebody's head, then at least understanding all this will help for the future when, more people actually get around to implementing it. So, but I
I think
appreciate the coding
just
part.
knowing it's there helps, right? I mean,
Yeah,
that's,
absolutely.
I mean, part of this class is just exposing you to things you might not see otherwise, and other parts of it are going to be very practical. Let's actually do something. So I think that's probably going to be a little bit it for MCPs, unless I can come up with a different example and we can implement it kind of, beginning to end. We'll give some thought. I have to give some thought to where we want to go next with the class. So if you have any ideas, feel free to send them over.
Cool. Yeah. Well, I'll make sure to stew on that and see if I can come up with anything.
That's right. It'd be very helpful. Any other questions? All right. That's it for this week. We'll see you next week. Have a great weekend. Hope everybody feels better.
Thank you, Tom. Bye, everybody.
Thanks, Tom.
Thank you,
Bye.
Tom.
Thanks,